let's do another proof. We're going to use the side angle side congruence theorem to prove that this top and bottom triangle is congruent. Now I'm given the information that BC is congruent to DA, so segment BC hash mark, segment DA hash mark. And we know if we're doing side angle side, we're looking for an angle in between two sides that are marked congruent. We also are told that BC is parallel to AD. This symbol means parallel, so let me make the parallel symbol. So those segments are parallel. Well, if you got parallel lines cut by transversal, one thing that they didn't mark that you have to mark yourself is that the alternate interior angles would be congruent. And literally I need that because I'm talking about needing a side and an angle and then another side. And since these right here are alternate interior angles and we know they're congruent if the lines are parallel, that will work. Also notice that AC is in, this segment AC is inside the top triangle and the bottom triangle, so it's got to be congruent to itself. So I can put my hash mark there, and then what I'll have is a side, an included angle, and a side. Side, angle, side. That's exactly what I need. Now I just need to put it into proof form. All right, so segment BC is congruent to segment DA. That was given. Segment BC is parallel to segment AD or DA. That is given. All right, I've left this one blank, but we marked these two angles congruent. So let's name them. That is angle BCA is congruent to angle, if it's BCA, that would be DAC. And we need a reason for that. Well, as we said a few moments ago, if parallel lines are cut by a transversal, alternate interior angles will be congruent. So I'm going to say alternate interior angles theorem. I'll abbreviate theorem. So we marked that, and then we had to come up with the fact that CA is congruent to AC. So segment CA is congruent to segment AC because this leg is in both triangles. So he's got to be congruent to himself. And if you remember from previous videos, that's the reflexive property of congruence. Okay, so what we have is that the two triangles are proven to be congruent, just like they ask, by side, angle, side. That's side, included angle, side. By side, angle, side, congruence theorem. And that's it. We've proven what we were asked to prove.